Hi everyone, today we're gonna talk about energy conservation. So, when do we use energy conservation for isolated system? So there is no external force is acting on this system. So, how many types of energy we have been learned so far? So far we have kinetic energy like from linear motion and kinetic energy from rotational motion and potential energy from gravitational force and potential energy from the elastic force. So it's like from a spring. What is the formula to calculate all those kind of energy? For kinetic energy, we have 1/2 mv squared. For rotational energy, v is the velocity. For rotational energy, we have 1/2 I omega squared. I is the moment of inertia. Potential, we have mgh. So from office hour, I start to get an impression I need to stress. So what is h here? So h is the height reference to the reference point, like where you take the height is equal to 0. For example, if we are seeing like on the surface, like on the ground, h equal to 0, then an object at height h naught has potential mgh1, and if an object is below this surface is at here m2 h2, then the potential energy of the object 2 equals to minus mg h2. What is the potential from the spring? It's if the spring is compressed by length delta x, then mu the potential equals to 1/2 k delta x squared. K is the spring constant. So if you want to do some problems to practice, like some practice problems to demonstrate that you know how to do problems from like energy conservation, you can try the practice exam from 2015, problem number 3, 4, and 5. I think problem number 3, they use conservation of kinetic plus potential energy, and number 4, it involved the energy conservation of kinetic energy and the elastic potential energy, and number 5, it involves the kinetic energy and elastic. Okay, I think number 4 is using the rotational energy and the kinetic energy and the gravitational potential. So you can solve these 3 problems to make sure you understand everything here. So I can do a quick example to see, to like it sort of introduce when do you need to use what kind of energy. Conservation. Okay. So now if we have a slope, all the surface has like no friction, and at h, and we have object initially here and final here. Now we have the energy conservation, EI equals to EF. This object is just gonna go this way, slide down, right? And there is no friction, so there is no energy loss. Then we have 1/2 mvi squared plus mj h1 equals to 1/2 mv f squared plus mg h2. If we set here h equal to 0, then h2 goes to 0, right? Here is we have like a project, it's just sliding down. There is no rotation involved. Now I'm changing the setting a little bit. If this object, if it's a cylinder or if it's a ball, it's rotating down the slope and to here, then we have one more energy involved, which is so what is this energy? It's the rotational kinetic energy because this ball is rotating. Okay, so one more setting I can add to this problem is I can add a spring in the end. So this object, after coming to here, this object is pushing the spring. The spring has been pushed by length delta x. So now we have one more energy involved in this energy conservation problem. In the end, there is some energy transferred to the spring, and the spring give us some potential energy is 1/2 k delta x squared. K is the spring constant. So here basically we look at this problem and so let's just quickly review. If it's an object, there is no rotation, then there is no rotational kinetic energy involved. If there is rotation, then there is rotational kinetic energy involved. If there is spring, then there is spring potential energy involved. Okay, so after knowing all this, I think you're good with energy conservation and the related problems. You can do some exercise.